Okay, so before we start with the optics problem, um, let me introduce a few things. So, based on my past experience, I've observed that a lot of students have problem making these diagrams. So, let me introduce a few things and rules that are needed. Okay, so first of all, we need to realize that this line passing through the center of the lens is called the optical axis or the principal axis. Okay, so in this case, we have an object. For calculations, we would be knowing two things. That is the where the object is placed and what the focal length of the convex or concave lens is. So the object over in this case has been placed at 2f in this example, so to say. And as you can see, we're taking this one single point of this arrow, and these rays of light, and these are all the rays of light that are getting reflected off that point. So in this example that says many, you can see that a few of these rays of light are passing through the convex lens. The principal one is the important one because it tells us about the three rules that we need in order to judge where the image is going to be formed. So one of the rules are any line that passes through the focal length passing through this convex lens is parallel to the optical axis. Any ray of light that is parallel to the optical axis then passes through the focal length after getting refracted from the convex lens. And the last rule is that the ray of light that passes through the center goes at it as it is, it does not bend. So, what we have to look out for is the intersection of any of these two lines. So, any of the two rules are enough. So once we get the intersection, at that point, we get to know okay, this is where the object is supposed to be, and this is how much height it is supposed to be. So, when we're drawing these, we'll get a rough idea or at least an exact idea if we're using a ruler to where the object is going to be and how big it is going to be. So once we're done with this example, now we can, since it's a simulation, we can see what else we can do. So we can move this back and forth and see how our image is being formed. And after moving ahead of f, we can see that the image that is being formed is magnified and it's a virtual image. So now, in the simulation, we can also do one more thing. That is, we can change the object. So let us change it to a pencil. So as you can see, this pencil is, as usual, kept at 2f. And there is one more parameter that is mentioned here, that is diameter. So if we decrease it, okay, the lens has become smaller. If we increase it, it has become bigger. But one thing that you can realize is if the diameter is small, the image that is being formed is a little dull. But if it increases, the picture gets clearer and clearer. And that is because the bigger the diameter, the more amount of light is going to be passing through, therefore, a clear image. This also implies a very interesting fact that if you were to cover half the convex lens, you would still get a real image. The only thing is, since there would be less light passing through, the image formed will be dull. Now, we can see the example of the concave lens, and while looking at the concave lens, you will see that it's always a virtual image being formed. So we can move back and forth the object, and you can see what is happening. So that's it, easy. Okay, so I think it's inspiring to know some examples of what we are learning in our daily lives. So let us talk about the human eye. Over here, you can see the eyeball and the objects that we see at the infinity. The rays being reflected from them converge through the eye lens towards the retina, and an image is formed at the back of the retina. But some of us have problems, and they can be categorized as hypermetropia or myopia. And so what happens in hypermetropia is that the image is formed beyond the retina. So this condition is called farsightedness, in which you can see far. And in order to correct this, you need a convex lens or a converging lens. Now, one of the important things to know while you're doing the calculation is that for a convex lens, f is positive. In the condition for myopia, which is known as nearsightedness, in which you can see close, what happens is that the image is formed before the retina. In order to correct this, you need a concave lens, which is also called a diverging lens. And important to note that the focal length is negative in this case.